Hello everyone, thank you all the attendees for joining us today. I hope all the attendees had a great time in networking with your peers in our networking lounges. A very good afternoon to all of you. I am Priyanshi welcoming you all on behalf of Solar Quarter and First Tree Group to our webinar on CXO Dialogue, new era of high power modules and inverters in large scale solar. So, before starting today's proceeding, I take the opportunity to thank and welcome our partners for this event. Platinum partners, Sineng Electric and Longi. We have a short video of our partners requesting my team to please play the videos.
Speaking of energy, what comes to mind? Petroleum or coal? Look up to the sky. The sun above our head has been releasing its energy since the beginning of time. With the worsening situation of global warming, renewable energy becomes the key to the sustainability of our planet. Utilizing solar energy, building a green world, has become Longi's mission, and we are taking actions towards it. Since 2012, Longi's PV product shipment has exceeded 205 gigawatts, which equals 9 times the 3 gorgeous dams' installed capacity. It has achieved carbon dioxide reduction of 204 million tons. To contribute to the sustainability of our planet, we have made further commitments. First, we are committed to fully utilizing renewable energy in all of our global operations by the year 2028. We are also committed to deploying our energy management system by 2025 to increase energy efficiency by 35%. There have already been significant results in 2021, as electricity consumption is reduced by 259 million kilowatts an hour, and carbon dioxide emissions by 151,230.10 tons. Besides, we are committed to installing an adequate amount of electric vehicle charging facilities in the next 10 years to encourage our employees to switch to electric vehicles for daily commute. To further progress, we have joined the Science Based Targets Initiative with the goal of limiting global warming to 1.5 degrees Celsius in alignment with the United Nations efforts to limit climate change. Heading for the future, what we do now matters. Utilizing solar energy, building a green world, is much more than a slogan. We pledge to continuously seek technology innovations to fulfilling our commitments. On the Earth Day of 2022, we are launching this special campaign, inviting all to collectively charge for a sustainable Earth. Longi.
The rapidly changing technology now plays a key role in shaping the way we live, work, and think. Faced with increasing challenges of global climate crisis, renewable energy becomes the key to a brighter future for the humankind. In 2014, Suneng Electric acquired PV business of Fortune 500 company. During years, Suneng has made solid progress in evolving into a world-famous enterprise. R&D strength is considered as the backbone of Suneng's leadership in solar industry, with its core members coming from Fortune 500 power electronics company. Based on that, Suneng Electric has successfully established 3 R&D facilities in Shenzhen, Wuxi, and Chengdu, China, specialized in electronic products and smart energy management. In the meantime, the company also set up a CNAS National Laboratory, an Enterprise Academician Workstation, and a postdoctoral research workstation. With the power of green technology, Suneng is now delivering its quality products to customers worldwide. Soon after entering India market in 2017, Sunung announced the inauguration of a 3 gigawatt factory in Bangalore. In 2021, the company expands the annual production capacity to 10 gigawatts, marking a milestone in the development of Sunung Electric global presence. Currently, Sunung Electric has 3 manufacturing bases in Wuxi, China, Wuzhong, China, and Bangalore, India, reaching a total of 30 gigawatt manufacturing capacity annually. As a leading global high-tech enterprise specialized in power electronic products R&D, manufacturing, trading, and O&M, Sunung empowers global sustainable development with its innovative technologies, state-of-the-art products, and tailor-made solutions. Sunung Electric provides a full range of PV inverter solutions, including residential, string, and central inverters, which can power ground-mounted, floating, C&I rooftop, and residential projects, satisfying the diversified demands of customers around the world. Sunung has reached a total shipment of over 40 gigawatts globally and ranks among top 10 players in global solar industry for consecutive years, covering major PV markets with fast-growing global service network. In the field of energy storage, Sunung Electric delivers to customers central and string PCS, as well as system integration products, applicable to power generation side, power grid side, user side, and microgrid. The products are widely adopted in various scenarios like thermal power frequency adjustment, peak shaving, wind and ESS, PV and ESS, peak and valley coordination, etc. By virtue of the proven reliability and well-recognized performance, Sunung is rated as top 1 China PCS supplier in 2021. As to power quality control, Sunung Electric provides all scenario products of active power filters, static VAR generators, smart power quality correction devices, which are employed in various industries like PV, semiconductor, communication, medical, rail transit, etc. Only by making constant efforts to move forward can the unlimited potential of renewable energy be fulfilled. In the context of carbon neutrality and energy transition, Sunung Electric aims to embrace a cleaner future, making solar energy affordable and truly benefits all on this planet.
And now, without further delay, we would like to initiate the session. We will be starting with a sponsor presentation by Mr. Habibul Jack from Sinang Electrical Company. Welcome to screen, sir.
Hello, Sakshi. Hello, everyone. Good afternoon. Let me first project the PPT. Is it visible?
Yes, sir, we can see your screen. Please share your PPT.
I'm already sharing it. Okay, let me open it again.
So please let me know if you require any help.
I think now it is okay. Is it visible now?
Yes, sir. Please continue.
Okay. Okay. Hello, everyone. Good afternoon. I am very glad to attend this webinar with you all, PV expert. In the presentation, my main focus I will put into techno-economical feasibility of inverter and module selection for increased module power to 600 plus watt peak, which is driving an unprecedented wave of sense in array designing and inverter configuration. So this presentation is divided into mainly two parts. In first part, I will be talking about the module development background, trends and implication on inverter module interface with increased module power very briefly. And in the second part, I will share some insight about our India manufacturing base. So let's get started. Here, I would like to take you back to the basics of the module production. Basically, silica is crystallized, and after a long process, we get cells. Cells are later assembled into module, then it is used in system. So in the mid of 1990 to 2022, we can see a clear growth in wafer size. In literature, these wafer are named as MO, M3, M4, and latest M10, M10 or M12. So these are the most popular wafer size in the last decades or half. But today's presentation focus goes to latest M10 and M12, whose size are 182 mm and 210 mm respectively. And power is 400 plus watt peak to 500 or 600 plus watt peak, and that we have available in the market. Uh,
Sorry to interrupt you, sir. Can you put the presentation on slideshow mode? We can't see the slides changing.
no, I haven't gone to the next slide yet.
Okay, sir. No problem. Please continue.
Yeah, yeah. So to manufacture high density modules with 182 or 210 wafer, different kinds of technology being used like park AC, multi-bus bar or half cut, etc. Some manufacturers are even using 7th generation park technology. Apart from that, we see variation in the cell gap, a small cell gap and zero cell gap is being used by some key players. For this, there are some related CTM laws as well. So, to understand the power increment with the increment of the wafer size, we need to take a step back into the PV physics. You can see a PV cell on the screen. PV cell is a current source. When sunlight comes into the cell, the photon collides with the electron, and electron will follow the less resistance path and follow through the cables. The number of the electrons generate is directly proportional to the irradiance. So PV cell is a radiance control current source. So current can be increased by increasing the irradiance, or if you keep the irradiance constant and increase the cell area, you will get more current. So larger the cell area, larger the current. Though the cell area increase, but the voltage remain same due to the half cut technology. So vendors basically cut not only the cell into half, but modules too, and connect series connected half cut cell into in parallels. So thus the voltage get reduced. So on the left side, you can see the current increment with different rating modules. So it goes beyond 15 ampere, and with rear side gain of bifacial module, it reaches up to 20 or 22 ampere or more. So for utility project, the system voltage is 1500 volts. We don't connect modules in parallel because that would lead to higher current, and cable loss will also be higher. So we connect them in series. So in series connected string design, which has priority VOC or ISC. In VOC higher and ISC less case, less parallel module connection and more series connection will leads to lower BOS cost in form of less combiner box, less cable, and less land occupation, etc. For a 3.125 megawatt block, we can see 445 watt peak module of 49.4 volt connect in series 26 per string, and 480 string get connected in parallel. So on the other hand, 600 watt peak module of 41.4 volt connected in series 32 per string, and 293 string get connected in parallel. So we can see the difference. Less module will lead to less land cost, cabling, and so on and so forth, reduction of other cost. So let's discuss the module production and logistic cost. As you can see on the graphic table, 180 mm and 210 mm wafer give us less wafer cost, cell manufacturing cost, and module assembly cost.
Sorry to interrupt
For
you. Can you do it
yes,
on full screen? The attendees are not able to see the presentation properly.
uh,
And
I'm
you
not
can
getting.
change the slides changing as well. Can you do it
Yes,
full
I'm
screen in the
I'm
slideshow
changing
mode?
the slides. I'm changing the slides.
Can
Can
you
you
do it
see
on
now
full screen,
module
sir?
production and logistic cost?
No, sir, we are not able to see that.
I think there are some network issues there. Can you see now? Module production and logistic cost comparison slide.
Yes,
Yes,
it is.
now we
Yeah,
can.
now
Now
it
it
is.
has moved.
But put it in
Oh,
the
okay, sorry.
presentation mode. Put it.
Okay, okay. I think there are some network issue. So in that graphic table, 180 mm and 210 mm wafer give us less wafer cost and cell manufacturing cost and module assembly cost. For large scale production, it is definitely economic. On the right hand side, we can see kilowatt peak that can be loaded in a 40-feet container. More kilowatt peak can be loaded of 182 or 210 millimeter wafer in comparison with 158 millimeter wafer. So I have since the next slide, BOS and LCOE perspectives. Considering the BOS and LCOE, 182 or 210 millimeter wafer will give more benefit. The number of the larger wafer based module is needed less than a small wafer based module, and other costs like mountaining, screwing, pile foundation, um, uh, combiner box installation, cabling, and land cost will also be reduced. The overall capex will be minimized in this way, so which in return will give optimized LCOE. So the total BOS cost will be reduced 5 to 10% in regards to different application scenarios and project sizes. I have gone to the next slide. So
Yes. Your slide is not moving. Can you check? Your slide is not moving.
So, do you
BOS.
want me to share the screen for you? I have your presentation slides.
Yes, please.
Okay, sir.
I think there are some.
Yes, sir.
So not this slide. We need to go to slide number 7. Yes, right. Okay. So for inverter, we usually look into two values. First one is IMPP, and second one is ISC. So as the current of the wafer is increased 9% with 166 mm, and 28% with 180 mm, and 75% with 210 mm wafer. Uh, Existing inverter solution will face some problem with it, and that is the limit of the short circuit current and MPPT current or operating current of the inverter. Please go to the next slide. So MPPT current limitation of the inverter, what does it really mean to inverter? So operating current is controlled by MPPT tracker by the varying the load, or can say controlling the voltage as seen by string or array from 0 to infinity. So when the current of the string or array will exceed the MPPT current limit, then it will move the MPPT knee point down to the lower part of the curve. So because of that, power will be clipped. So though the inverter with lower power, lower MPPT current rating will operate, but we cannot harness the maximum power from the array, and which ultimately will lead to lose some power. Please move to the next slide. So these are the solution available in the market: 185 kilowatt, 250 kilowatt, and 275 kilowatt. First, we look at the 185 kilowatt solution. So MPPT maximum current is 100 ampere, and it has less only 3 MPPT tracker. So there are associated higher mismatch loss, which completely don't fulfill the purpose of using string inverter. From 250 kilowatt solution, maximum MPPT current is 30 30 amp, and there are 12 MPPT tracker. Even though 210 millimeter wafer module single string is connected with the 12 MPPT, but the DCAC ratio will be less than 1, as only one string of 18 ampere or more can be connected with one inputs. So to get rid of this problem, Sinang Electric has come up with 275 kilowatt inverter in 2020, which is tailored for higher power module, and each MPPT maximum operating current is 40 amp, and each MPPT provide two string interface. Ma'am, could you go to the next slide? So this is our flagship product, which has gigawatt installation around the world. It has 115% overload capacity, and same series SB model has 120% overload capacity. So the protection level of this inverter is IP65, and it is grid friendly, has LBRT, SBRT, and ZBRT functionalities. Next slide, please. So as the maximum short circuit current of the central inverter is higher, so there is no constraint in array designing with high power module. However, the input fuse breaker ratings of the combiner box need to be adjusted. Along with that, the DC input fuse rating will also need to be adjusted. Next slide, please. So 275 kilowatt inverter tailored for high power module. Maximum output power is 275 kilowatt. Maximum current of each string is 20 ampere. It has 12 MPPT, total 24 inputs. Next slide, please. So with the evolving PV technology, Sinang Electric inverter has also been evolved over the years, 50 to 175 to 250, and now we have 275 kilowatt. 275 kilowatt inverter can work with all kinds of wafer sized module like 166 mm, 188 mm, and 210 mm wafer. Next slide, please. So, vocal for local has become a trending slogan, and to contribute to Make in India goal, we are deeply engaged in localized manufacturing since our first appearance in the India market. Bangalore factory in India is covering 96,000 square feet area, has 10 gigawatt annual manufacturing capacity, and more than 200 employees is working at the moment. Dedicated string and central inverter production line and testing bay are equipped there. Next slide, please. So out of this 10 gigawatt, 8 gigawatt central and 2 gigawatt for string inverter are designated. Most left side we are looking at the string inverter production line, and then central inverter production line, and then burn-in chamber and specialized module assembly room. So I have come to an end of this presentation. Thanks all for your attention.
Thank you so much for this insightful presentation, sir. It was really engaging. Moving on to our next sponsor presentation, we have with us Mr. Siddharth Ravindran from Longi. Welcome to the screen, sir.
Yeah, thanks, Sakshi, for queuing me in. Am I audible?
Yes, sir.
Yes.
Please proceed.
One second. So, is my screen visible to you in full screen?
Yes, sir.
Perfect. So, very good afternoon, everyone. So, before we go ahead with the presentation, I'd like to thank Solar Quarter for bringing together such an esteemed group of panelists and putting together this session. It certainly is a pleasure to be presenting in front of such a well-renowned audience. So let's start with a little background of our brand Longi. So we kickstarted our operations in the year 2000, and in the early days we were into manufacturing of silicon ingots alone. We started off with monocrystalline wafers when the market share of mono was barely 2%, and today, after 2 decades of vertical growth, our team currently stands at about 60,000 members strong, contributing to a turnover of more than $12 billion with a net bottom line of close to 1.5 billion. But what we're really proud of to share with you is that more than 5% of this revenue is invested in R&D, as you can see, about $700 million to be precise, which truly reflects on our commitment to innovation. So this, in fact, makes us the largest spender in R&D among pure play PV companies. Moving on. So we happen to be the world's largest wafer manufacturer. In fact, we consistently hold a 40% market share of mono wafers supplied globally. So you could most certainly believe that 1 in every 2 or even 3 wafers supplied all over the world is from us, which itself is a significant achievement. And for context, our wafer capacity has reached over 105 gigawatt, and we've supplied more than 70 gigawatt of wafers last year alone. In 2021, we broke our own record that we set in the previous year and became the first manufacturer to surpass 30 gigawatt of module supplies in a single calendar year. We, in fact, supplied about 38.5 gigawatt of modules globally, to be precise, while our capacity touched a little over 60 gigawatt at the very start of this year. Also, more importantly, in India, despite starting our full-fledged operations relatively late, that is in 2019, we managed to be the top supplier for 2 years in a row, and we closed the calendar year 2021 with about 3.8 gigawatt of supplies. Overall, by the end of Q1 this year, we have completed about 7 gigawatt of monocrystalline module supplies in India, which again is the highest ever by any brand in India. Now, to lay some emphasis on our financial strength, apart from being listed as a 100% bankable entity by BNEF, we also hold the highest Altman Z-score among module manufacturers of 6.3. The Z-score, of course, being a measure of safety from bankruptcy. Obviously, we are far above the threshold value of 2.99, whereas companies with a score of less than 1.8 risk a high chance of going bankrupt. We've in fact topped this rating for multiple quarters now, or even years, I would say, consecutively, which speaks volumes about our sustainable growth strategy. So, more importantly, as of Q1 this year, we are the only AAA rated solar PV module manufacturer, which says a lot about our organization as a whole as well. So, we passionately believe that the best warranty that we could offer as a PV module manufacturer is by staying strong financially, because 25 to 30-year warranty periods could not be backed up by anything better. So this is a quick glance at the bankability pyramid listed by PV Tech. This was released in February this year. Now, to take you through a timeline of our innovations, you could see that we've been committed to monocrystalline technology right from day one, and we've continued to push through barriers and pioneered in many technology advancements such as the diamond wire slicing technology, the CZ ingot pulling process, etc. We've basically revolutionized the production process, which brought down the cost of mono wafers significantly. And by 2016, we started making the case for PERC technology, particularly for monofacial and bifacial purposes. And we eventually followed it up with the half cut technology, which is widely used today in almost every module sold globally. And we also recently revolutionized the wafer industry with two new standard sizes, wafer sizes, the M6 and the M10 wafers. And basically, the modules based on these sizes drastically contributed to the reduced LCOE in PV plants that we see today. And as of today, we are still striving to develop modules which are far higher efficient, and you could probably expect us to, disrupt the industry pretty soon with the next large-scale commercial technology after PERC. And here's a quick look at our latest breakthroughs in terms of cell efficiencies. The latest being in June this year, where we set yet another world record for HJT solar cell efficiency of 26.5%. And not to mention, all our products are top ranked by TUV in the power generation simulation. They're ranked by PVL as the top performer in module reliability scoring over a 5-year period, that is, between 2017 and 2022. We also hold the award for the highest power generation since 2018 from PV Magazine. And of course, we're also one of the highest achievers in the PV module index set by RETC. Coming to one of our mainstream products, the bifacial PERC modules, we are using the glass-to-glass design with the POE encapsulation for better reliability. An interesting fact is that in 2021, that's last year, our bifacial modules contributed the most in terms of product mix in supplies. In India, particularly, about 85% of our supplies were from bifacial modules. So, as predicted by us back in 2017 itself, the market is increasingly shifting towards bifacial modules, and this trend is only expected to continue in the years to come. So typically, we recommend that our bifacial modules be installed at a minimum height of about 1 meter to make maximum use of the albedo. In India, we've got companies like, say, Infosys and Bosch, who've already installed large-scale rooftops with our bifacial modules, and they've been giving good results already. And of course, apart from the ground clearance, the bifacial gain would largely depend on the albedo, the array pitch, and also the purlin designs. So this is a quick look at the gains observed at various project sites and test beds across the world. We've observed the best gains of up to 20%, as you can see, with white surfaces where the albedo is particularly maximized. In fact, we also have a pilot plant in Chennai, which was tested by TUV. And in their observations, we've seen that the bifacial gains from our module has peaked at 19.2%, which very much supports our claims in terms of gains. So just by paying a meager, 1 to 2% extra cost for a bifacial module, you could expect a gain of more than 8 to 10% on an average easily. So the value proposition of a bifacial module is easily more attractive compared to that of a monofacial. So this is a summary of a report published by PVL based on their test bed in California with bifacial modules from various top manufacturers. You could clearly observe that our modules have exhibited the most bifacial gain during the test period. That's between 2019 and 2020. So let's do a quick rundown of our current offering for the Indian market. That's the HIMO 5 series modules. So these modules were launched about 2 years back with the M10 wafers, and as of April 2022, we have completed more than 20 gigawatt of supplies. So we've made sure that this model, particularly fits the market needs and requirement quite precisely. And so this is your typical 540 watt peak HIMO 5 glass to glass bifacial module, which has a current rating that is more or less universally compatible for all string and central inverters. You could also notice that the size increment or even the weight increment when compared to an M6 wafer module is quite minimal. And as far as the value chain is concerned, we are laying a lot of emphasis to standardize most of the items in the module BOM. By bringing all these items under our own brand, our brand's umbrella, we would certainly be in a position to insulate ourselves from any sort of short-term supply shocks and ultimately be able to support our clients better. We've also been quite conscious on our choice of materials and design for our modules. For example, after multiple rounds of evaluation, we refrained from using transparent backsheets as they were evidently prone to yellowing, cracking, delamination, etc. So we continue to hold on to our conviction of the glass-to-glass design, which has predominantly proven to be the more reliable offering in the market. And we, in fact, also walked an extra mile to collaborate with our suppliers to develop a 25 ampere junction box using a single diode for our module. So what we found was there's a significant risk of uneven shunting in the two diode design, which could impact the overall module reliability in the long run. So that's the reason we stuck to a single diode design. And just to quickly touch upon the very common misunderstanding that bigger the module size, better the BOS savings. Being the unequivocal leader in the industry in terms of both technology and market share, we've been quite relentless and in our advocacy that M10 based modules are the optimal size and also the boundary size for large format modules. For instance, our module width is not more than 1.13 meter for a reason, and that's mechanical stability, to be precise. Apart from this, with the M10 modules, you get better production feasibility because of the supply chain alignment. You get low micro cracks, better system compatibility because of lower current ratings, easier module transportation with the traditional landscape packaging rather than the vertical arrangement that you generally tend to see now. And also, of course, easier installation with only two workmen needed to lift a single module comfortably. So in fact, you can also have more number of modules in a single string or rack thanks to the lower width of the M10 modules. And since the length of main axis of a tracker is fixed these days, this comes into play in a very big way. And also the perceived savings in terms of cable cost in case of larger modules are completely dismissed, I would say, in our analysis, because even at higher currents compared to the M10, 4 square mm cables are still being used in place of 6 square mm, which tends to increase the line losses considerably. So, all of these advantages have really translated into numbers as well. You'd be surprised to know that the share of M10 based models in the market today is 56%, as opposed to 26% with the larger format wafers. And as per latest reports, even by PV Infolink, this gap is only forecasted to widen in the future. So it's pretty clear that the M10 is a more universally recognized and well accepted technology in the global market. Finally, as far as sustainability is concerned, we have taken active steps to be part of the EV100 and EP100 initiatives. We're also proud to be part of the famed RE100 club, where we join a very small but prestigious list of companies like Apple, Microsoft, Infosys, Tata Motors, etc. So, as a part of this, we've pledged to satisfy 100% of our electricity demand from renewable sources within this decade, by 2028, to be very precise. And with about 15 manufacturing bases currently under our belt and many more to come, we believe that this is indeed a significant step towards a more sustainable future. So yeah, that's about it, I guess. Thanks everyone for being such patient listeners to the entire presentation. Thanks again. Appreciate it.
Thank you so much, sir, for this interesting and insightful presentation and setting up the tone for the panel discussion. So, now it's time to begin with our much awaited panel discussion, which is on CXO dialogue, new era of high power modules and inverters in large scale solar sector. And to discuss this, we have in our panel with us Mr. Sanjay Narula from Clean Energy Limited, who is the moderator for today, Mr. C. Chaudhary from Sterlite Power, Mr. Rabindran Sundar Singh from Acme, Mr. Habibul Jack from Sinning Electric Corporate Limited, Mr. Gautam Samanta from Juniper Green Energy Private Limited, Mr. Siddharth Ravindran from Longi, Mr. Saurabh Agarwal from Kewa Tech, Mr. Sudhir Pathak from Hero Future Energy, and Mr. Tejaskar Reddy Depa from Radiance Renewable Private Limited. Now I welcome all the panelists on the screen and requesting Sanjay sir to lead the discussion. I would just like to make a small announcement here, requesting all the attendees to post their Q&A in the Q&A box. Our panelists will answer those questions after the panel discussion. Thank you. Over to you, Sanjay sir.
Yeah, good afternoon, everyone. Yeah, good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Yeah, there seems to be some internet connection, but hope it gets better. So, thanks a lot for the presentation. They were interesting presentations by Sinang and Longi. So, uh, have all the experts from the industry with us today. Uh, in order to kick off this discussion, my first take would be on a few questions that I had, and it would be good for people and attendees to know from the speakers. And this is to Mr. Jack, Habibul Jack. And we would like to know there has been a lot of discussion around three level topology and the seventh generation of IGBT technologies. So, what is it all about, and what have been the recent technological innovations in inverter with respect to its being smart inverter and its interaction with the grid? So that's a quick one for Mr. Habibul Jack in case he's able to hear me there. Hello.
He's on mute.
So, this question can be passed to somebody else. Habibul sir is not here with us.
Yeah. So in the meanwhile, let me go to Mr. Siddharth Ravindran from Launchi. With respect to a lot of, the question is mainly focused around a lot of variation in the wafer size. People getting into, M10 and M12. So I think there's a lot of confusion with the manufacturers as to what is the size that will eventually be predominantly there. While you very clearly said it's gonna be M10, uh, but still, please illuminate the attendees and the industry at large as to what is the size that you see and why is this confusion happening, and what do you think would actually be the size which would be prevalently available? Siddharth.
Yeah, thanks, Narulaji. So, to address your question, I think we'll have to take a step back and understand where the industry was about 3 years back. So, we were all stuck to the 156 mm and 158 mm, that is the G1 size wafers, even in the polycrystalline technology, just about 3 years back, not too long ago. And with the advent of M6 and consequently the M10, the size of the module obviously increased. But we also have to understand that the modules come with certain boundary conditions. When I say boundary conditions, these attribute to the mechanical loading of the module. They attribute to comfortable transportation and installation of the module as well. So, considering all these factors, uh, Longi, being the leader in monopoc technology, being the pioneer in monopoc technology, has understood and has evaluated that M10 is the final boundary condition for modules, and any size above that, particularly in terms of width of the module, anything beyond 1.1 meter or 1.15 meters, is going to reduce the mechanical loading of the module by easily 40 to 45%. So that's one reason why we've particularly stressed on this fact that uh, M10 is going to be the way for the M size M10 is going to be the way forward, and a lot of developers and IPPs across the world also are resonating to this fact, and we've in fact beaten last year's estimates. So this year, uh, M12 was supposed to have higher market share compared to 26%, but because of the M10's strong stance, which increased from 42% to 56%, M12 has gotten stagnated at 26%. So right now, it is safe to say that the gap between M10 and M12, the market share gap is definitely going to increase in the years to come.
Understood. Understood. Thanks, Siddharth. So, do you see a agreement being arrived by the wafer manufacturers some point in near future that they become the universal size, uh, standardization happens on the size?
We hope so. I think the top three manufacturers globally have, agreed to use this particular size. That's the M10 wafer size. So I think predominantly this should be the technology. I mean, even in terms of practical viability for installing it on the field or even for C&I rooftops, I think
Sure.
M10 has to be the way forward more than M12.
All right. All right. Thanks. So I see many of the experts, my colleagues, waiting in the lounge to enlighten the attendees. So I'll move to Mr. Gautam Samanta. Samantha Saab, you have been an expert on modules for a pretty long time. You have been following this industry very closely. So there's been a lot of discussion amongst monoperc and monoperc, bifacial, and topcon. Some people are very bullish on topcon. So while I see some of the attendees, the previous colleague Siddharth saying that bifacial with glass makes a lot of sense because there are challenges with the transparent backsheet, and I somehow also perceive that glass any day is a much better substrate than backsheet. So, what's your take on the technology, evolving technology, and how would the market share among these three players? Topcon is very minimal as of today. Among monoperc, bifacial, and Topcon evolve, or HJT for that matter. HJT appears to be a cumbersome process. So kindly deliberate on this so that uh, attendees, there have been a lot of seminars also on these subjects happening very frequently. So kindly help and enlighten the people by a little more deep diving onto the subject uh, of
Okay. Yeah.
what's
Yeah.
going
Yeah.
to be game for the future.
Yeah. Thank you, Sanjay ji, and thank you, Solar Quarter, for organizing such a beautiful webinar. If you look into the industry, the BSF, which is called the vanilla cells earlier, right? In 2000, I think at 19, it was now obsolete and you don't get it. So Park is the major focus, and this is on with the monofacial and with the bifacial configurations, right? So as on market like 2021, we had seen that 75% of the total production is from the Park. And in 2022, yes, Topcon is taking over. But if you look into the both the configurations in terms of the devices. Like the park is mostly coming from the P-type wafers and the TOPCon and HGT with the N-type wafer. So looking onto the different, I'll say, the specifications on the module, and when as a developers we evaluate, we look into the things. It's not only the first year degradations and also the subsequent, the year on year degradations. And the next point is that the temperature coefficient, which plays a big role in India, right? So with the present conditions, if you look into the park, the temperature coefficient is 0.35, per cell per degree Celsius. But if we go into the top cone, it is 0.29. And if we go with the HGT, it is 0.25 or 0.26 somewhere, right? So therefore, so there is a eventually huge gain with the device change from the P-type to N-type. It's not only that, even if it is the P-type, we see the first year there is another factor is called LID, light induced degradation, right? So the LID, from the warranty point of view, the manufacturers gives 2%, but I believe I had seen a witness it is 1.2 to 1.3% on the higher side,
Right.
sometimes side. And I know all the best quality cells they are producing. So a lot of the module parameters which are coming from the inherently from the cell, the characteristics of the solar cells, right? So even if you go for LETID and then PID and the other effects, so in the P-type, there are some, it's a little disadvantage over to N-type. When you go for the N-type, so there is no boron oxygen or even the gallium doped. We had seen a little bit lower than the LID, but in the N-type material, we get a better performance, and even it is not a zero LID, but very, very low LID, I'll say, right? And that's the biggest advantage. But from the manufacturer's point of view, they gave only 1% degradation. They want to keep it safe, right? But it's very, very low. I'll say 0.2, 0.3%. The deal, you can say, right? And it's not only that, the temperature coefficient also plays a big role. And year on year degradations depend upon the two configurations, what you told. If the bifacial module with the glass is always what you told is better, in a sense, like 2 millimeter glass in the front side, 2 millimeter glass in the rear side. From the mechanical strength point of view, it is better. And the other point you have to look into the things is the moisture engraving. When we talk about the from opaque to transparent back seat, the front side is 3.2 millimeter glass, but rear side is a transparent back seat. Means the property of the back seat, it doesn't change. What does it mean? That means there is a moisture engraving per square meters from the back side. So if there is by any chance is there is a cell crack, then there may be some snail trail or any kind of effect which may come. I mean, there is a chances,
Sure.
by handling, either mishandling or because of some weather conditions, either maybe high storm or high speed in above 80 kilometer per hour, so there is a chance, right? So going to the N type, and particularly from the capex point of view, those who are manufacturing, yes, there is a delta. That means couple of steps from the part to the top corn, 2-3 steps you have to improve. But as far as the HGT is concerned, the capex is quite high. I'll say another 20 to 25% more, and you cannot change over from the park line to a top corn line, right? But even in the top corn also, I mean, from the manufacturing point of view, on the rear side, particularly the 10 nanometer oxidation layer, and then you do a kind of a, drilling and tunneling. There are challenges, but I know all these modules and the cells are bifacial in nature. If you look into the HGT, the front side and the rear side, the front side will be the positive and the rear side will be the negative. But in case of a P-type material, front side is negative and back side is positive. But both the TOFCON and the HGTs are bifacial in the nature. So therefore, from P-type to N-type, the bifaciality improves from 70% to 85%. That means if I install a bifacial modules either in a transparent gas backseat or in a glass, so if I my gain is say for example if the fixed tilt is 6%, right? So I'll get another 15% more gain. That means almost it will be a kind of a 6.9 to 7% gain from the same configurations with the kind of a TopCon or HJT, right? And there are several advantages on the year-on-year degradations. And see, it's not like that. So this particular topic, what you ask, is a high power module. Is not only that, but you have to discount on the reliability and the improvement of the performance on a year-on-year basis. So at the end of the day, I want to say that particularly on the park module with the glass, you say 87% is the power you get after 25 years, but in a TopCon you'll get somewhere the 90. With the HGT you'll get 92% power. So therefore, if you check in terms of the power or the energy yield, it's much better for a technology perspectives. But as on date,
Commercially.
commerciality, there is a things that the cost wise you have to see that where it comes with your LCOE configuration. Thank you. Noor.
Thank you, Samantha Saab. So while what you are saying is that while TopCon and HAT are definitely beneficial because they use N-type cells and you have lower temperature coefficient of minus only 0.25%, which is for Indian condition is an excellent. Means it used to be only thin film module which would offer a few years back this kind of a temperature coefficient. So if you ignore the commercials, cost economics, so definitely TopCon and HJT are highly technological, better technology and higher reliability product. So probably it's gonna be, in my opinion, it's going to be mono perk and bifacial continue for some more time till the time the cost reduction in the manufacturing processes of TopCon and HJT. Maybe they find some innovative ways to reduce the prices delta,
Right.
and then compete with the get very closer to what bifacial module is.
True. So volume is actually the numbers in like 40 gigawatt this year. The TopCon has been in the production, and maybe 140 gigawatt will be the park. So therefore the ratio is changing. By 2030, the ratio 60% will be on the N-type devices, including TopCon and the HGT. So
Sure,
this will be
understood.
changing.
On the glass to glass, I'm sure, and I think glass to glass definitely makes a lot of sense as compared to the transparent backsheet, because backsheet being the backsheet, it offers you and gives you the same kind of failure mode, and it's probably the weakest link in the entire module encapsulation. The unit, the module,
Right.
it's the weakest link where you have moisture potential of moisture ingress, not potential, but it actually happens.
Yes.
Breathing in and breathing out continuously takes place during the day and night, and it's subject to, and that's one of the key failure modes of module degrading over time, for the fingers and bus bars getting oxidized, gradually getting yellowed, and
And
that's one of
powdering
the,
and all, a lot of other, yes.
and the suppliers and the OEMs are already offering, I think, 85% end of 25 years or end of 30 years, and with lesser degradation over year with glass to glass module. So that's a big plus. That's a big plus with the bifacial modules.
Right. The top side is 2 millimeter, the bottom side is 2 millimeter glass. So it gives a better symmetry in terms of the mechanical strength and device configurations. Right. Those are the advantages.
Sure.
Thank you.
All right. Thank you, Samantha Saab. I would like to invite Mr. Pathak. Pathak Saab, please, in a similar way, I would request you to do a little deep diving on the kind of technology we have in inverters, how have been inverters developing in the last few years. I've been reading a few articles here and there and found that there's some 3-level topology. So what is this 2 level and 3 level topologies. I wanted Mr. Habibul to ask that question, but since he's disconnected, I would request in case you could throw some light on it. And also, what is the seventh generation IGBT technology? What I've been reading through a few papers that the size of the IGBT has reduced, and the switching cycles have increased lately, and also the grid have become, with the use of AI and ML, probably they have become more interactive and they can interact with the grid on, voltage and frequency changes and some self-governing kind of mechanism.
Yeah,
So, so
thanks,
kind.
Sanjay sir, and thanks, Soda Quarter, for bringing me here. So, yeah, I think after the module, which I say as the, like you can say, heart of the system, inverter is the brain of the system. So definitely, so there it comes how we can make the brain work more smarter. So, sir, like three-level topology and two-level topology are, you can say, almost 2 to 3 years old thoughts, because they are in vogue. See, fundamental thing is two-level topology where you have IGBTs in one arm. You have two sets of broad level IGBTs. Three-level topology is where two becomes two different stages, or you can say there are three or four sets of IGBTs. But now the things are being discussed with the five layer or five level topology, right? Which is a combo of IGBTs and diodes. The only reason behind is that the main you can say guzzler of loss is switching, because more you switch, there is more LDI by dt losses, and also I square R losses. So if you can minimize the switching losses, you can improve the efficiency of your inverters. So that is one of the fundamental things which is driving, and more the losses, you have to put more of the fans, and its maintainability will increase. You have to put more of heat sinks that will make your system heavier. And now we are moving to a stage wherein anybody wants completely maintenance free, fault free devices where he can kick off and then replace with new. So for maintenance free, that means you need higher uptime, right? For higher uptime of the things, although sometimes it goes in other way around, that you should, if you have less number of components, it will be more reliable. But the component IGBTs are there very, very reliable. But only thing is that if you minimize switching losses, your ancillary equipments like inductors are they, which are working as filters, those
LCS
who are
filter.
trying to suppress the harmonics. So less of harmonics, your inverter's life, your inductor life will increase. Typically these components fail more, right, in these devices.
Peripherals.
Yeah, these peripherals, because and so less of switching losses, more reliability that it automatically brings to the system, because you have more number of IGBTs in the series. So less duty cycle these IGBTs have to bear in. Now, coming to the light that you were referring to, so the lightweight comes from lightweight of inverters, or the higher energy density comes if you, as I told, like reduce the ancillaries. If your heat sink weight, because heat sink IGBT is very light, the higher weight is of the heat sink, or the higher weight is of the inductors inside it. So
Right.
how you can make it lighter, by reducing the size of heat sinks. How you can make heat sinks lighter by minimizing the heat loss, right? And the same way the inductor. Now IGBTs also have some limitations. Now the trend is going to be with the SiC kind of IGBTs, means as I means not silicon pure, what we say. It is now silicon carbide based IGBTs which are coming in vogue, which also give further more lower losses, switching losses, right? And so lower the switching, lower the harmonics, and your THD compliance will be better. So this is about the heart of, you can say, that particular brain what we have. But now I think I've been telling in other webinars as well that these things are giving slight improvements. These are not, you can say, exponential improvements. So the improvements are going to come only if we can utilize these devices smartly. So as you named it, AI and ML. So all these, I shall say, string inverters. I'm a fan of them. So this is like if you are distributing the brain all across the ground,
Absolutely.
and your brain has its own eye sensors who can look to each and every even module itself by
Absolutely.
its AIML. So I perceive, and as we know that 5G auctions are already over. So the better way to innovate is how you can synchronize both the worlds. So like the communication technology with your solar technology and inverter technology. So from that standpoint, I believe that yes, as we go with the high level topology, we are going to see further improvement in the efficiency of the inverter. Number one, further improvement in the MTTR, mean time to repair, and even MTBF, and that's not enough. Now as we have more number of eyes, like more when I say eye, that is, and that is you can say your like you have lot many MPPTs. So each MPPT is your eye, which is looking at the modules. So as your number of eyes are increasing, you are more vigilant on each and every component of the module. If you add the intelligence of AI and ML into it, algorithm into it, because humanly it is not possible to go and check each and every module and do the assessment as we used to do earlier in small plants by taking the tongue tester running around the people. So with these artificial intelligence and embedded along with, there are several tools which now there are several companies who are working over and above that, which are developing the artificial intelligence based system which is making the solar plant prescriptive. It is not only that your IoT called inverter works. You can make several more IoTs, your transformers, even which inverter can see. Even your module temperatures can also be seen by the inverters. So then they can give, then there will be an top level software residing in the system which can tell that this particular transformer, this module is going to fail or going to prove lower, go and attend it, and also tell how. So I think the world is going there. So that is very very important that we should choose that selectively, not only from capex perspective, but from operating perspective. Yeah, so that's it from me.
Absolutely. Thank you. Your words on string inverter, catches fancy with me. I've always been fascinated by string inverters, and not even string, even micro inverters. While we were doing benchmarking for our plants in Gujarat in 2011-12, probably 10 years back, we found a particular plant which was an outlier, which was, different, distinctively different and higher in efficiency as compared to our plants. And on investigation, we found that this particular plant, this particular guy had deployed 1890 string inverters of 5 kilowatt each for a 10 megawatt plant.
Hmm.
And it was, delivering about 5 to 6% higher generation, while we were chasing for every half a percent with module cleaning and those kind of basic stuff. So then why not get into micro inverters where every module MPPT is tracked and you are able to harness the maximum out of every module.
Uh,
So
Yeah,
Sanjayji, just
so
to add, oh, I'm sorry,
yeah,
Siddharth here.
please go ahead.
Just to add, the 5 kilowatt inverter was a single phase inverter that you're talking about, the 1890 numbers. Yes.
I'm not sure. Yeah, it's long
It,
backstory, but they were
yeah, that was in
18.
2011. I had made that sale. So,
You made that sale, huh?
yeah, that was an NKG infrastructures. So, that was
NKG
1890 numbers.
infrastructure,
Yeah.
right? NKG infrastructure, and not only that, we found couple of more people who were doing single axis tracker in those early days when it was not so prevalent, and people were shying away to build it into capex. And we were most of the people were building just plain vanilla plants with multi-module and central inverters.
Yes, sir,
So
and so like what Ravindran told, and even what Gautam sir told, that now uh, future is all bifacial, whether it is residing in Perk or in Topcon or in HJT. So in any case, whenever it becomes bifacial, so each module is unique by itself because it is dependent on its ambience. So then you have to be having a system which can look at it at each module and behave and try to optimize or maximize its throughput. So that's why it's a no-brainer.
Yeah, I think. Thanks. I think that brings a lot of insight into what the inverter should look like and be in the future. Uh, so I would invite Mr. Ravindran Sundar Singh on a different perspective. What would Ravindran Saab, what is it that you would like to talk about with regards to module and inverters? You're on mute. I believe you will have to unmute yourself.
Yeah, thanks. As a developer, uh, both these developments are both in the module space as well as the inverter space. Is both these developments are very interesting, and sometimes we do try to even drive the change, especially in the inverter side. We do attempt to influence the designers and the inverter manufacturers. I do hold meetings with all of them. I try to have at least quarterly meetings with the manufacturers, giving them the feedback, giving them the requirements, both short term and long term. And once you have a certain volume of purchase, most of the leading manufacturers are able to listen to you and to really improve their product also sometimes. So that is, but I'll come back to that later. Uh, but the most important thing for a developer, because there are so many changes which have taken place in the last 2 years, the most important thing is change management. If not just the designer, I'll come to it, even the people who are for example, taking high level decisions. There was a time when people would buy, uh, say, modules separately, trackers separately, inverters separately, and you can always put it together, right? Even if it's a fixed tilt, people would. Some companies are still doing this. They install the structures, and they've still not ordered the module, right? But if you can imagine, this is one of the things that has to change. The mindset change has to come, that no longer I'm able to fit these new modules on the old structures, on the existing, the structures which are built 3 months ago. Similarly, there is this mindset that I will order the module last of all. Last 3 months, I will order, quickly bring it across, immediately start generating. Whereas today, if I were to order a tracker and install it, and kind of hope that the module will fit in there, because you see the module decision has not been made. Any variation, say even 10 in the width of the module, is 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 almost impossible sometimes to fit on the same tracker. The length of the tracker changes, the number of modules in series changes, the wind load changes, the foundation design changes. So we have to get the horse before the cart now. Modules will have to come a little in advance. At least the module will have to be finalized and locked in before I can start manufacturing my trackers. So this is one of the high level mindset changes which has to go in
On a,
place.
on a different note, Ravindran Saab, if I can ask you, I've come across a few developers who are trying to see the module prices are going sky high. They are rocketing. With the BCD coming in, the module prices are beyond anyone's imagination. So some developers are toying with the idea of finding tier two supplier and importing from them. Do you think it's worthwhile? Would it pay off, or means personally, I see a lot of failure mode, and I see potential issues if we are, depending on tier two unqualified, kind of splash. What do you think? What would be your suggestion to those developers?
Yeah, yeah. I have my friend here, Sudhir Patak. He is very vocal and he's got very strong views on this topic. But I'll still stick my neck out here. Uh, it's like this. You see, tier one is just defined by, defined in certain parameters which are not necessarily linked to the quality of the module. Okay,
Yeah,
so that's the first thing. Tier one
just the
is not
size.
equal
Yeah, the
to
size.
quality. Now, having said that, there are, for example, so many tier two manufacturers who are comfortably making 2, 3, 4 gigawatts in a year. Now, uh, here's the important thing: whichever supplier you buy from, it's important that we have a hands-on quality control there. We have to get into their quality processes. I have to go and inspect their cell vendor works, right? I have to uh, make sure that the committed bomb materials are used, right? And unfortunately, due to COVID, we are not able to go ourselves. We are forced to use local third parties, which is not quite the same thing. We are forced to use local testing labs in China, which again, with all due respect to them, I'd rather test independently somewhere else. So it's very important to have a very robust quality process. Trust
Understood.
but verify. Trust but
Got
verify.
it.
So if you do that, you can very well go with the less known manufacturers. But obviously you have to ensure that they are solvent. They have the backing of some larger organization which can ensure that they are able to, for example, make good on their warranties. So all those checks and balances you have to ensure,
Sure.
but we can use these people. Yeah.
Got your point. I think well taken. Thank you very much, Ravindran Saab. I would like to invite Mr. Teshekar now with a question primarily focused on. We talked a lot about module and inverter. What kind of modules? How is the technology going to evolve, and what is it that we should be careful for while buying those equipment? But what are the important things, Teshekar, in your opinion, which need to be taken care of to get optimum output from these equipment, modules and inverters on an ongoing basis, the routine, checks and balances, uh, so that they continue to deliver the desired outcome year after year.
Yes. Thank you, sir. Thanks for the question. So, thank you for the solar quarter also for the opportunity. So, I would say that when sir today, each and every day, the market is actually volatile, and the projects which we are doing, it is depends upon the module prices. So today, if you can able to see down the line 3 years before, so tracker is not a feasible because of the module price is not up, not into the up to the mark. Okay, so today if you can see the BCD is up, is imposed, and the prices are going high. So now the trackers are coming into the picture. So if I see the design aspect of that one, so the ultimate energy generation which you are getting from the output from the solar system, okay, so it everything is depends upon the situation and the market demand as well as into your pricing. So that is more important. Whereas come to the LCOE, so where we earlier see that when the unit rate which comes to 1 rupee, 99 paisa and 2 rupees, but today you can see the recent tender results. It's went up to 2.9, 2.96, something like that. Okay, so I feel that when the module thing is very very important. And second thing I would like to emphasize on the one particular point on the Ravindran sir has said the module manufacturing process, where we today we are facing an issue with the when we are importing a material from outside, we are going to pay the 45% of the BCD charges, and if we import a same type of a cells into the Indian context, and we will do a manufacturing process where few of the manufacturer has a facility of 540 and 500 watt peak of panels, there you can end up with a 27% of what do you say, the cost. There you can able to save almost 17.5% of the BCD charges, and it is more viable and economical to do a project also. So coming to the technologies, definitely the future is going to be a TopCon modules, and a tracker and bifacial modules is going to be entire this thing, unless and until if, because we have seen in the polycrystalline modules earlier in the initial stage, we are going with a higher rate, higher cost of that. But now you see the park modules also we are getting very less before the March 31st. So now today we are ending up with a huge cost of that. So it is a time, but definitely it is going to be a drastical. It will come down, but we have to see the quality things is very much important. And while designing, I can say that the tracker is more reliable for the upcoming project for the current context of the module prices keeping in mind. If the price is going down, definitely all the economics and everything is going to change.
All right. Thank you very much, Teshekhar. Thank you very much. I would like to invite Mr. Saurabh from Kehua uh, to talk about what kind of inverters are best suited for Indian conditions, whether it is string inverters or central inverters or smaller inverter versus containerized solution, which are going all the way up to 5 gigawatt or 5 megawatt, or probably getting bigger also by the day. So what do you think?
Thank you, Sanjay ji. Thank you, Solar Quarter team, for inviting me. So, talking about the inverter technology, we have seen in the past, inverters are majorly dependent on the type of market. So, in India, we divide the market into three parts: residential, CNI, and commercial, or utility. Utility is all ground mount. So, as per the trend we have seen in the past few years, the utility market demands the central inverter because of the price concern. So central inverter has played a very good role in terms of commercial and in terms of technical, because single phase was the most preferred choice of all the IPPs. So with the change in time, we have seen the IPPs almost 70 to 80% and move to string inverters, whereas they were initially demanding a string inverter in a higher power or high wattage. Just like the modules is keep on increasing in terms of power, so inverters has also done a drastic change in terms of wattage. So the technology, since the module moved from 1000 to 1500 volt, so 1500 volt brings a 250 kilowatt string inverter for a utility scale, which started up in the year 2019 end, and which has been the most preferred choice of all the IPPs till date. But as we go ahead, we have also seen there is a drastic demand of high wattage of string inverter. So the next offering what we have for the utility scale is the 320 and 350 kilowatt string inverter. So the changes what we have seen as compared to central inverter versus the 350 or 320 kilowatt string inverter, or you also can compare it with 250, that all the major features what we were offering from central inverter, like HVRT, LVRT, nighttime SVG, you know, we were offering multiple MPPTs in central inverters as compared to our competitors. So we have kept the same trend in string inverter also by increasing the number of MPPTs. And in the past few months, we have seen, or you can say in the since last year, the central inverter, which was all containerized, like IP55, wherever everybody was supplying two inverters inside 120 feet container and connecting it with an ACDB and making it IP55. So similar way, the central inverters has become outdoor now. All the central inverters has become modular outdoor IP55, and some we also have an option to offer you IP65 inverters in that is up to 2.5, 3.125 and 4.167 megawatt of rating. So we have seen the trend in central inverter increasing towards 4.167 and 5 megawatt. Similarly, the trend in the string inverter, which started with 250 kilowatt, which was IP65 C5 anti-corrosion protection, has kept the same pace, where 320 also come with 12 mppt, IP66 C5 anti-corrosion protection, your LVRT, HVRT, nighttime SVG, all the features inbuilt. Plus, there are few more extra features which we are offering, as Sudhir ji and everybody was talking about the brain of the plant, which is the inverter, and brain is spread all across the plant. Plus, the eyes are there. So, MPPTs are the eyes of the system. So, you can say 12 MPPT with 40 ampere current per MPPT, which is very well designed and prepared for the highest wattage module available. So, as the trend is moving towards M10 and M12 of the cell dimension, so this inverter is best suitable for all the application, whether it is 540, 550, 600 or upcoming 650 watt peak module. So technology wise, we have seen that there is no comparison in terms of central versus string. The IPPs or the clients which are more comfortable with the central inverters, they still prefer to go with higher wattage of central inverters like 4.167, 3.125 or 5 megawatt. But the IPPs which still feel that there has to be a redundancy in the plant, the eyes has to be spread, the brain has to be spread all across the plant so that they can get a better generation. So they are now moving towards the string inverters. So as the market move ahead, we might see after 350 kilowatt a higher rating of string inverter, maybe next year end or the year next to 2023. So technology is yet growing, and we have seen that most of the people by end of next year will surely move towards the string inverter. Yes, talking the
All
commercial
right.
point of view, India is a price sensitive market, but yet we see a lot of BOS saving in string inverters, so which attracts clients towards string inverters.
Thank you. Thank you. So, one last question. Do you have any plans to set up a factory in Bangalore? Most of the inverter manufacturers have put up factories in Bangalore. Uh,
Uh,
I I don't know how come Bangalore happens to be a choicest destination. Is there something typical of Bangalore that helps inverter manufacturing?
Not exactly, but it's all about the first mover. So there was some
Oh,
of our competitor who started first, and then the other follows. So again, we were having plans in 2019, and we were very serious. Our chairman also came down. He visited few sites. We had a very big plan because we when we entered India market in 2017. So entered means we did one small project of 2 megawatt for energy storage, which is one of the oldest project we have done in India market, and it is still running from past 5 years. So in 2019, when our chairman entered India, he visited India. So we were very hopeful, but again, 2020 was a bad phase for the world, because COVID breakout. There was an outbreak of COVID across the globe. So the plan was on the at the back stages, but the competitors who are already having factories, they started up way beyond 2020. So that is why they are still able to sustain the factories. And if you talk about the Chinese people having factories in India, so out of, you can say, 20 25 people, vendors from China, hardly 3 or 4 vendors has factories in India. Rest everybody is supplying from China. So yes, coming to the main point, we have a big vision to have make in India. We are working on it, but once it is, we have a clear picture from our top management, we'll surely be discussing with all the solar quarters and other advertising companies to have a
sure.
news release, press release done in the.
Sure. Thanks. Thanks for your time, Saurabh. So
Thank you,
I
thank you.
think we can go to Priyanshi now, and we can take questions, Priyanshi.
Yes, sir. So I would like to inform you that we don't have questions, so we can close the session on time. So I would like to thank all the esteemed panelists for this wonderful session, and a very special thanks to you, Sanjay sir, for superbly managing the session. As always, you were impressively well prepared and extremely professional in the way you kept us all at the height of our attention for more than an hour. Plus, you were phenomenal in making the panelists appear at their very best. Thank you everyone for extending your time and support for this event. We promise to come back with more such exciting topics very soon. Till then, bye from Aaron and take care.
Thank you very much. Thank you, everyone.
Thank you. Take
Thank
care.
you.
Bye bye.
Thank you.